Hello and welcome to Unplugged, an IIoT podcast where we delve into the fascinating world of Internet of Things and automation. I'm your host, Phil Seboa.
G'day, Phil, and I'm Ed Fuentes. Well, Phil, today we've got a very special guest with us, Bryce Anderson, next to us. He's the founder and director of Lifecycle Controls. Interesting, this one today, Phil, because we're going to be playing in that building automation system space, building management system space. And the good thing about Bryce is over 25 years of experience in this space. And it does lots of things to help businesses enhance their building performance, operational efficiency. He's got a great story ahead of him. I think both of you and I have watched a bit of his content online and would encourage anyone listening to do that later on. But Bryce, welcome to the podcast.
Hi, great. Nice to meet you guys. Look forward to it.
Absolutely. So, Bryce, before we dive into the technical details of BMS systems, can you tell us a little bit about your background and how you found your way into the world of building management systems?
Yeah, sure. I actually, strangely enough, I actually originally studied process controls. So like in a different world, we could have been sitting here talking about the exact same thing. But I guess when you're young, you don't know that the very first job you get probably sets up your whole career, right? So yeah, in the late 90s, I got a job with Johnson Controls in South Africa and they're doing building automation, and that's what just set my path. You know, I'd also applied for jobs that looked at Toyota or Coca-Cola, and if I got those jobs, I would have gone into manufacturing and process control. So interesting. So what sort of happened was originally in South Africa in the late 90s, around 1998, started with Johnson Controls working in building automation as a sort of like a project engineer, doing mostly commissioning, bit of software programming. And then in around 2001, I went to London. I was in London for 9 years. And, you know, first year, again, a commissioning technician. Then I jumped across from construction into service. I was a BMS service technician for about 3 years. And that was mostly because I had a 1 year visa and needed a longer work permit. And the construction teams were just one project at a time. So, you know, at the end of my job, they're like, we don't need you anymore. So I went to service and I got a 4 year work permit with them. So yeah, 2 years of commissioning in South Africa, 1 year commissioning in London, about 3 years mobile service technician. Then I was a service projects engineer, mostly, you know, doing project work on existing service sites, mostly upgrading building management systems, you know, putting in new controllers, servers, things like that. Then I did about, say, 4 years of design, so full-time BMS design, designing the networks, the control strategies, points lists, valve schedules, mechanical boards, all that sort of stuff. And then in about 2010, I got a sponsorship to come to Australia, landed in Melbourne as a BMS project manager for about 4 years. So the first 15 years of my career, basically in 3 countries and on the tools, doing the work, right? But after sort of 15 years of, you know, heavy construction, it's like, well, wear anybody out. And I was like, man, there's got to be an easy way to do this. You know, every job and I'm sure your industry has similar issues around like the lowest price wins, and there's just lots of like challenges, right? It's really hard to deliver a good outcome in construction land. So in about 2014, I then transitioned into consulting. So I went to work for a large building services consultancy in Melbourne called Norman Disney & Young. And they were doing like all services, mechanical, electrical, fire, hydraulics, security, vertical transportation, sustainability, acoustics, the whole thing. And I was their building management system consultant for the Melbourne office. So that's sort of like where I learned how to do consulting, because, you know, even if you know how to build something like the tools, the database, the software programming, you know, the machine, like consulting is completely different. You got to think a completely different way around, you know, how do you talk to customers and how do you, like, they explain their problem in a way that makes no sense. You got to write up a specification that puts in like contractor language, how we're going to solve their problem. So for about 3 years, I was working on like $1 billion projects with NDY. I was doing the BMS specification with the mechanical engineers, coordinating with, you know, the electrical engineers, fire, you know, hydraulics, coordinating all the monitoring and the control for the BMS. And then in about 2017, I decided to go out on my own. So in 2017, I started Lifecycle Controls. And the main reason was around, I don't know how it's in the manufacturing industry, but in buildings, the mechanical consultant usually does the building automation design. So it's the mechanical consultants that are doing that specification. And I felt there was a need to have a specialist person doing the BMS design, doing the specification. And I wanted to sort of like grow that sort of side of the business where clients had an option not to engage mechanical engineers to do control system design. They could engage directly a specialist to do that. And I also wanted to do other things like, BMS training and coaching and sort of mentoring type stuff, which didn't fit with sort of their business model. So yeah, since 2017 till now, doing mostly consulting work on sort of BMS upgrades, 30-story commercial offices, writing a specification, going out to tender, doing the tender award, then 12 to 18 months of construction phase. I do mostly that, and I do a lot of some new construction work where I'm mostly working for the actual client, and they want an independent specialist. There's a big, massive construction project. It's the usual thing. They just want someone that's got their back. So mostly that's sort of like client side type stuff. And as I said before, training and things. So that's how I got to where I am now. Really actually super grateful to have worked in the BMS industry, because like even my industry and yours, it's not a very well-known thing. Like you don't go to the pub and someone's like, what do you do for a living? I'm like a control systems engineer, or like process controls or PLCs or SCADA. They're like, what? So, but it's been a really good opportunity because I got sponsored. I got work in London. I got sponsored into Australia. I probably wouldn't have had those opportunities if I was just doing some other sort of job. So, all those people that are thinking like, oh, I wish I was doing like something more like flashy, like RT type stuff, whatever it is. We're in a really good industry because, people can't do what we do, right? So, yeah, so now I'm sort of living in the Sunshine Coast, moved up here a few weeks ago, working from home full time, living the dream. So it's all turned out okay.
Absolutely. Going from like on the tools to, designing, very sophisticated BMS systems. So you need some of that context around that. You need to be in the trenches. You need to have a bit of the blood, sweat and tears of pulling, the cables through ductwork and, cable ducting and all these kind of, hard points. I can definitely, talk to that, being a London-based electrician as well, pulling those cables through, some of the dirtiest areas of the city space as well. So yeah, you can definitely understand some of those challenges around them as well. I guess we're talking around, that BMS space, the building controls, the heart and of most of these, high-rise buildings or office blocks, residential, all these areas. I guess we want to, delve into that a bit deeper and see how can building managers, utilize technology to both maximize the lifespan of their building assets and improve, overall performance of those assets.
I actually have like a different opinion on this to sort of a lot of people. Like I have this idea that like technology on its own does nothing, right? You can like build a technology application, sort of fault detection in the cloud, all sorts of stuff, right? Like it does nothing on its own. So what we need to do is what makes a difference really is when humans use technology. I think sometimes people forget that. People think that I heard this, what the saying once was that technology is the cherry on top of the cake. It's not the whole cake. Like technology is this cherry on top. At the moment, everyone's sort of carrying on about, AI and machine learning and all this technology type stuff, and everyone's focusing on the technology. But if you really want to maximize the effectiveness of technology, you've got to start thinking about the humans, the people that use the technology. And that's what we're not doing very well. So for example, if you're like in a commercial office and you've got like automatic fault detection, and there it's in the cloud, and there's like, it's crunching like thousands of bits of information, crunching all this data, and it generates sort of like insights and things, right? So, but it's always a human, like a service technician that has to execute on that insight. So the insight comes through, then a BMS service technician or a mechanical, electrical, so they've got to take that bit of information and go and fix or do something. So if you really want to enhance the effectiveness of technology, you've got to get humans more into it. And what that usually might mean is something like, what no one does is when you buy technology, you should actually restructure completely your maintenance contracts. Because those maintenance contracts, that preventative maintenance contracts, the existing ones don't talk about what to do with the technology. So in a worst case scenario, what could happen is there's a service technician, they go to site 1 day a week and they're doing preventative maintenance. So they're checking sensors, checking valve actuators, they're checking controls, power supplies and stuff. Nowhere in their contract does it say, oh, by the way, when you get to site, log into the technology platform, log into the workflow management tool and see what's been allocated to you, what tasks you should go and clear, go fix those things, come back, tick them off, right? A lot of companies will say, hey, that's great, love that. We're going to be paid to do that because our current contract says we're going to come to site and look for broken things. Right. It doesn't say we should collaborate with your technology provider. It doesn't say we should come to a meeting once a month and, action all these things and be proactive. So a lot of companies will put their hand out for more money rather than trying to integrate themselves into the tool and to sort of maximize its effectiveness. They're not doing that. And I see it all the time. Building owners have to raise work orders to go and action or execute analytic insights. So if you have technology, existing technology, fault detection, energy management type stuff, whatever it is in buildings, and you want to maximize the effectiveness, you've got to restructure the maintenance contracts so that those technicians come to site, get a cup of coffee, log into the technology platform, what's been assigned to me, and be a part of the machine. So people are forgetting that it's if you think about it, a technology application crunches through tons of data and it finds something in the weeds and it creates an insight. That insight should create discussion between the owner and the contractors, and then discussion leads to enhancements or modifications. There's a real complex workflow around taking technology and embedding it into the way companies work. And that is what we're not doing at all. We've got to, and that's not what most people would say. Most people say, oh, we can get if we use AI and stuff and machine learning and IoT, we can get massive effectiveness and better return on investment. That's not the answer. Everyone's forgetting about those guys and girls in safety boots walking around plant rooms because they fix the things you find. They tune the control systems. And I think you would find if you got deep into this that it's probably easier to deploy technology than it is to change how a company has been working for 100 years. That would be harder. That's harder to do that. We did this one job at a big hospital in Melbourne, and we sort of restructured the BMS maintenance contract to solicit not just doing preventative maintenance. They were there 5 days a week. It's a massive contract, 5 days a week, full-time attendance. We want 3 days of awesomeness. So for 3 days a week, you'd tuning control systems, modifying things, updating documentation, doing some energy efficiency projects, and you can spend some time doing your traditional preventative maintenance stuff. And the account manager was like, that's really great. We like the idea of this. However, our technician has been coming to site 5 days a week for 20 years. I'm not sure if you'll do it. And I was like, are you thinking that? I don't heard you say that. Are you thinking it because you're saying it? That's not my problem. Go work it out, right? So deploying technology is probably easier than getting big global, corporate Fortune 500 companies to change how they do business. So yeah, if you have technology and you want to maximize its effectiveness, you've got to integrate technology with the people that actually fix things and use the products.
Yeah, we see that. We see that quite a bit, Phil and I. We are obviously with technology. We love technology. We adopt. We find the benefits, the values that technology brings, and I think you've seen it too, Bryce. Over the last 25 years, you've seen technology come in, probably not being adopted by all the players in the space. Some players have done it. One of the videos you mentioned how the opportunity was there for the BMS companies to take advantage of technology, but they found it out that they ignored it, and other businesses have adopted it, and now you've got this system of many data sources or many different businesses. And you can almost replace the word building management for manufacturing in what you're saying, because we see the same issues. We probably don't have the same level of contracts like you do for building management, where you have these 15 or 20-year service contracts that you typically sign up for these large applications, where we typically see the maintenance crew of a factory or a manufacturing plant have internal support. Same thing, 20, 30 years experience is how we've always done it. And now and again, they'll subcontract that out to other service agents that are just selling hours. But this adoption and the benefit of technology, yeah, very true. It's easy to implement it, and it's even cheaper now to implement technology. But you mentioned it's the people.
I actually think that this is like my personal opinion. Like, I might not be right about this, but Australia, in my opinion, were like early adopters of technology. If the rest of the world, like, because of the last 10 or 15 years in commercial buildings, we've been doing a lot of technology stuff, right? So early adopters. But I think that in a lot of cases, these big building owners, portfolio builders, have been just buying technology for the sake of buying technology. Kind of cool, we're buying technology. We're early adopters. We've been buying technology for the sake of buying it. And I just sometimes think that people are starting to realize now, hang on a second, like, I'm not sure if I'm actually getting a strong return on investment here. Like, technology is not cheap. Ongoing subscription services, and like, I don't know about you guys, but you might have like a few like manufacturing facilities, but some of these big building owners have 100 buildings, 100 big towers, so those technology monthly subscription services add up to like millions of dollars a year of subscription services. So yeah, we're at a point now, I think, in commercial office land where some people are sort of saying, hang on a second, like, where's the return on investment for this?
Yeah, we're definitely seeing that sort of thing. And that crossover between BMS and industry. Most of these larger corporations have office-based customers, right? Lots of opportunities to manage their efficiencies across their manufacturing landscape. Their process lines are one, section of that overall picture, but they've generally got huge amounts of, infrastructure behind the doors, the in-house administration of those people. And and it comes back to that people portion, right? You need people to be able to leverage technology to be able to.
And we all know there's less skilled people around, right? So that just like compounds the problem. We don't have lots of skilled people.
Yeah, because of the fact they've got these manufacturing customers that we probably tend to listen to us and we talk to. Are there strategies that you can take from what you've seen in the building management game or that commercial game that they could maybe manufacturers can look at employing some strategies or strategy that can help them about their efficiency and their productivity? What are some of the things they should be focusing on to get good impact or biggest impact for their businesses?
Yeah, and their best bang for their buck, right? As you mentioned.
You were like, where's the crossover between, where's the lessons learned in commercial office land, right? That's a tricky question because it's like, in commercial office, we can, one of the ways that you save energy in a commercial office is that you don't control to the design conditions. So say, for example, we've got a chill water system that's pumping like 6 degrees Celsius chill water through 30 floors of a commercial office, right? The design is 6 degrees Celsius chilled water, 12 degrees Celsius return. And there's the system pressure out there is, 200 kPa of pressure. So we're controlling our pumps to that pressure and we're controlling chillers to temperature, blah, blah, a whole bunch of different things, right? But in commercial office land, we can break the rules. We can, if it's not hot outside, we'll start knocking that pressure down from 200, 190, 180, pump slow down, save energy. Or we increase the chill water temperature from 6 degrees Celsius to 7 or 8. That saves energy. So we have the advantage that we can actually, no one's going to notice a 0.5 degree Celsius extra temperature. In the office, they're not going to notice like 5% extra humidity. They're not going to notice, 50 parts per million of CO2. So we have a massive advantage, and a lot of energy efficiency in commercial offices is deviating from the actual design to get those savings. You can't do that. Otherwise, the beer tastes bad. So you guys can't muck around with the design, right? That's the design. It's going to work like that. But I'm sort of thinking that, assuming that the manufacturing industry is starting its energy efficiency journey. I don't know. I'm assuming they're starting it. You're sort of like 15 years behind commercial office, right? So you're 15 years behind us in this journey, and you're probably not going to go from like 0 to hero in a year or two. You've got a journey ahead of you. So I actually think that some of the complexities around how to save energy is probably maybe not your priority. Your priority is in this early phase is to start sort of collecting data and sort of visualizing this data and preparing yourselves. Because like, have you guys heard of Neighbors ratings? And you guys have
Yes.
have you ever spoken about that on your channel?
No,
No,
I haven't.
I've heard of that. It's at the NABERS, isn't it? That Neighbours. Yes.
Yeah. So it's like a long time ago, more than 10 years ago, the Australian government sort of implemented this building energy efficiency rating program. And, all commercial offices had to get these energy efficiency ratings. You have to do it. And that was like a game changer for energy efficiency for us, because now all of a sudden it was public knowledge, information as what your buildings and energy efficient was. So if you invested money and you raised your star rating from a 4-star to a 5-star, you could attract higher profile tenants who would pay higher rent. So, government for a long time wouldn't go into buildings under a 5-star rating. And I think they might have raised that now to something else. So we had this big carrot. If you invest money and you improve your energy efficiency and you improve your building's energy efficiency rating, you could earn higher rents. And people were doing that. So you've got say you're buying a washing machine. There's a 3-star one, a 4-star one. Which one are you going to take? The one that's uses less power, especially they cost the same. So that's what happened to us, right? And if we didn't have that that sort of carrot to do that, we probably wouldn't have done anything. And that's why some other countries, in my opinion, like in the US perhaps, where they don't have that legislation, they've sort of been slower to sort of adopt that sort of stuff. Now, recently, Neighbours has been expanding into other sectors like hotels, maybe data centers. I don't know, would they ever expand to manufacturing? I don't know, maybe not. But what I was sort of thinking about is, and this is just my opinion, not a fact, don't repeat this, but what governments are signing up to? You've got 1,000 people listening to the podcast. I'm saying don't repeat it. None of you there repeat it, right? But you got there's governments all around the world signing up to net zero, right? They've got no idea how to do it. Probably impossible, but they've got no idea how to do it. Now, government's track record, in my opinion, is to put the onus on somebody else. So through the Neighbours rating, they put the onus on us to save energy commercial offices. So I think that one day, just making this up, that there will be these carbon credits for buildings, residential tower, carbon credits, data centers, manufacturing lines. And if you go over your credit, you get penalized. That sounds like what they would do, right? So what you guys should be doing now is gearing up when that happens, is to start understanding how you're using power in your manufacturing lines and prepare for those penalties. So I was sort of thinking, because data centers have a thing called PUE, power usage effectiveness. And I'm not an expert in this, but it's something to do with understanding the power that the data halls use for the server equipment, the servers and things, and the power that is used to support all of that, which is mostly cooling for air conditioning. So they're always looking at that relationship between the hall uses much power and how much power does the cooling use. Now, I was just wondering that probably also relates to a manufacturing facility, right? How much power is the process using? Conveyor belts, robots, whatever it is. How much power is that using? And how much power is the facility using to support that? Which would probably be mostly air conditioning. But back of house offices, admin areas, engineering workshop, all those areas. So if you started to install electric meters, clamp on electric meter type things, and you start to understand that power usage of the process, and you start visualizing that information. This is phase one. Now the customers can see, I use this much power on the process, this much power here, and you start doing things that starts coming down just a little bit every year. You can start sort of socializing that win, celebrating that win. So I actually think that I don't think you can save power in the process unless you bought better variable speed drives or whatever it is. You can't change the pressure or the temperature or whatever it is you're doing, right? So, but it's that other part that you can work on. So yeah, I think for that sort of discussion around in a manufacturing facilities, how do you save power? Obviously we could go into days of talking about how to optimize chill water systems if you have chillers or cooling towers and those sorts of things. But I think phase one is start collecting data, getting it into a data warehouse, start visualizing that information actually in a way that's useful to the owner. Start doing that and start gearing up so that when these penalties come or the incentives come, you're ready to rock and roll on that. So yeah, it's not giving you a clear answer about how to actually do it, but it's this idea that before you start optimizing things, you've got to get ready.
It's definitely a focus at the moment,
Yeah.
So the Queensland government here is really focusing on ESG, though. So there's
really?
economical,
In
sustainable in manufacturing,
Oh.
exactly. So we've started these initiatives, as you mentioned. It is the start of a very long journey towards that being, carbon neutral. Even producing energy on site, locally to support those manufacturing facilities as well. So we're seeing some growth in that point. The latest, I guess, greenfield sites are really taking considerations on taking a net zero approach, being even carbon neutral in that sense, and having one potentially big solar arrays on the buildings, having on-site water treatment so that they can recycle the water usage that they're using to pump that back into manufacturing processes, as well as heat generation and capture as well. So if they need to heat the buildings, they can, through that manufacturing process, they can capture that heat, redistribute it into the office environment should they need to, and use that as part of the cooling system.
Makes complete sense, right?
Yeah, exactly. So we're just trying to create these like closed loop systems where we're not taking as much energy from the grid, and we're actually just utilizing it. So yeah, the Queensland government is definitely looking at that as a bit of a focus for their latest roadshows as well. I see in North Queensland they're doing a bit of a roadshow around ESG. So it's definitely a focus for the future of manufacturing here in Australia, and we're definitely seeing that in our the trade shows that are coming up as well. So yeah, taking all those things in consideration when we're starting to build out these data driven decision making kind of thing as well.
We're seeing it here too, Phil, down in Victoria, not just manufacturing, but that whole emphasis on energy. Obviously the suppliers, that both supply via coal, the renewables, they're looking for ways to make the network better. And manufacturing does consume a lot of that power. I'm sure the commercial places do, but there seems to be a strong understanding. What you said, Bryce, is spot on. They're all looking for more data. And the problem is that there's data already in those plants. You mentioned in some of your videos about VSDs. VSDs are like energy meters. They've got data on them already, but a lot of them don't capture all that information out of the VSD. They don't capture the data that exists already on the plant, give it that context that they need. Lots of food industry, for example, use refrigeration, freezers and chillers. They're massive heat load. They're massive energy consumers in those places. They're also looking for that. Sometimes their profit is made just by reducing the energy costs because they all run pretty slim margins.
That's it, yeah.
And just basically using, that you mentioned proactive maintenance, right? Just, leveraging that sort of process change from a people side, right? To be looking for these indicators. When should we be going in and doing maintenance events? Reducing the amount of wastage, right? Actually extending the life cycles of these assets and buildings to be able to kind of live that, really efficient life that we're trying to really get ahead of. I guess, just to go a bit off topic there, the BMS systems out there, I guess, what are the challenges around, that data collection portion? I mean, what are you, it's probably very similar to the manufacturing space, I would say.
Well, the BMS collects a truckload of data already. Like, you wouldn't believe it. Like if you have a 30-story commercial office, which is like an average, just large size, not 50, like 30 is big, right? There could be like 1,000 controllers in that building, like 1,000 PLCs in a building like that. So, the thing with like process controls is that you're like a very reliable control system, goes very fast, quite expensive. It's doing this job, but the BMS has another challenge where we've got like much more information to deal with. It's a bigger, there's like, I'm not joking, 1,000 controllers, thousands and thousands of hardwired points, the Footscray Hospital, the new hospital at Footscray, has about 1,500 electric meters. 1,500 electric meters. You know how much Modbus networks and gateways and Ethernet and cabinets and stuff to deal with that, right? So the BMS already has massive amounts of data. The problem that the industry has is they want that data in the cloud. That's what the problem is. We have the data. Like, I think for you guys, you might not, like, in a process environment, I'm guessing you're only installing the instrumentation that you need to control the process. You don't have nice to have stuff in there. You don't need that. Don't put it in there. The BMS has a lot of stuff in it. So our challenge isn't how does the BMS deal with the data? They're already dealing with it. It's there already from day one. It's how do you get the data into the cloud? That's what everyone's problem is, because, and there's a lot of issues around that. Like, you're talking about, like, wanting to do something with the data, but it's hard enough getting good quality data. For example, right, the BMS is designed with its server and all its IP networks and 1,000 controllers and massive amounts of data. But it's just doing its little thing like this. It's designed to do this little thing, controlling the air conditioning, monitoring the fire panel, monitoring the generators, lighting control systems, hydraulics, water, gas. And then we take a server in the cloud and we plonk it up there and we start hammering the BMS for data, like polling it, like. And there's an energy management system server polling, and like the BMS, like, hang on a sec, I wasn't designed to do this. I was designed to have one supervisory device, my server, talking to me quite slowly about temperature stuff, slow. So our issue is that we have like multiple, servers in the cloud, like hammering the BMS for data every 1 minute, because everyone wants like real-time data in the cloud, right? So yeah, our issue is not how does the BMS deal with data. The issue is how do we get the data into the cloud? And if you've got a portfolio owner of 50 buildings, how do you structure that whole data warehouse for 50 buildings? It's like it's a big deal.
Wow. Okay, let's stay on that data topic there, Bryce, because that's where the gold is. But interesting scenario you mentioned is getting the data out nicely in a way that doesn't smash all the other controllers around and let them stop doing their job. So what does that look like for you? I mean, how do you see it being fixed? Data is important. We know that. It's a powerful tool. You need data. The asset managers need the data. Like you mentioned, if you own 20 or 50 commercial buildings, what do you do and how do you manage data? Bryce, how do you see it doing? How can it be better?
I'm not sure about that. There's so many like challenges with this sort of thing. Like one of the issues we're having at the moment is a portfolio owner has 30 buildings, right? And they want to do technology stuff. They want automatic fault detection, analytic stuff. So they go into market and they choose a company they really like this company. Oh, I really like them. Got good visualization, good tools. And then that company comes along and they put a gateway on site and they start pulling the data out and they put that data into like a data warehouse, blah, 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 right? And the next building. The problem is that in most cases, that technology company owns that data warehouse. It's their account with Microsoft, right? So now the owner has 30 buildings worth of data, in a data warehouse that they don't own. So like this whole thing of the data thing is it's loaded all over. It's like a whole separate discussion. It's very difficult to do it.
Do you think they want to own it? Do the commercial builders want to own the data?
Well, they do because they're locked into that company because their database. Like what the owner should do is the owner should go and open up their own account with Microsoft and set the whole warehouse up and normalize all the data, clean it all up, all the names right, the structure right, and then they should get the technology bolted on top of it. So if you want to change your analytics provider, you just say, we don't want you anymore. Someone else comes along, connects to the warehouse. So, but we're only learning this because we had to learn the hard way. No one thought about that 10 years ago. It's just now we're learning, hang on a second, I can't change this company. And of course, all technology companies market that, hey, we can open up your data from the lock-in of the proprietary BMS provider. That's like their sell. You don't like the BMS company, it's proprietary. Let us unlock the data. Meanwhile, it just gets locked in somewhere else.
Yeah.
Indirectly and completely by accident, not intentional.
I mean, it's the same story wherever you go, to be fair, right? Like it's manufacturing has been getting those, that challenge for a long time, right? These proprietary software platforms. I guess that's why we're starting to leverage more open source platforms as well, where we're not locked behind, proprietary protocols, dedicated hardware. We're decoupling the SCADA type implementations to allow for that, that freedom.
You know that we learned that hard lesson on your behalf, right? You learned that from us.
Right.
You heard us crying about it, and you thought, "Oh, look at that! They messed that up. Let's do something different."
Exactly, but it's such a funny thing. I mean, me and Ed work with so many different industries, and we hear the same challenges, right? It's the same thing. How do we get our data more efficiently into the cloud infrastructure? How can we do it in a way that is not going to break the bank, right? These polling type mechanisms are not meant for cloud. Right, like it's just the way that these models are put together. So that's why we focus on this IIoT type of approach, where we can start leveraging those open protocols like MQTT and OPC UA to be able to transform and distribute this data at scale, because that's what IoT is all about, right? That separating from the industrial application of IoT, but IoT is about scale, and we're seeing that in that commercial space.
It has a lot of problems, though. It has a lot of problems, like deal breaker problems, in my opinion.
Okay. What kind of deal breaker problems are the red flags for BMS?
Let me give you my super negative take on this. All right. So apologies in advance. So one of the issues we have is that everybody is trying to sell their customer something. Like, we all want to sell the customer something. That's what we want to do, right? And I just don't. We're trying to sell indoor air quality sensors. So a lot of companies build an indoor air quality sensor like CO2, temperature, humidity, dust, noise, whatever, VOCs. They sell these things, and they just desperately want to sell thousands. They want to sell these things, right? They want to make as much money as possible. Like the whole gig is about how do you make money, not solve the problem. So what happens is you buy one of these sensors for $500 and you plug on a wall, and it goes up into the cloud, into a database, some beautiful visualization, IoT stuff, right? And if we use indoor air quality as an example, an indoor air quality sensor doesn't improve indoor air quality. The sensor doesn't improve indoor air quality. It just tells you. So what happens is you buy the thing for quite a lot of money, get it into the cloud, and then pay a never-ending subscription service to host that data to tell you something. We need that data in the BMS, because the BMS is the thing that actually controls air, like volume of air. So the BMS will open those dampers and run those fans and bring more outside air if it knows about it. We need the indoor air quality sensor straight into BMS. That's where we need it. In the BMS, a network exists, a server exists, graphics, alarms, trends, reports exist, the controllers exist, power supply, the whole infrastructure lives there already. You already bought it, you already paid for it. Get it into there. The problem is if you're a person that's designing and building CO2 sensors, you don't want it to go in the BMS because you don't have the subscription service in the cloud. You want it to go to the cloud. That's what you want. So it gets up in the cloud, and they say to the customer, look, so what you do is here's your information, it's your data, and now the BMS can get it through an API or something, which is correct. But like most BMS engineers or PLC SCADA engineers are not going to know how to get that out of the API. It's too complicated. It's not in their area of expertise. So, and you need after like about 3 or 5 years, you're going to start a battery replacement program. Now, it depends on how many you have, but in a commercial office with 1,000 zone temperature sensors, which is a normal number, 25 on the floor, 30, 40, 50 floors, if they're wireless sensors, you're in big trouble, because at 5 years, you will start a never-ending battery replacement program. Like it's, just run the cable, bite the bullet, get it in the BMS. So, of course, there's a place for IoT stuff. I don't want to come off too negative, but as a core control systems person, I want the data in a place that I can actually use it to change something, and I don't want it to be in the cloud. So
100%. So maybe it should be, instead of being a BMS, should be a BMDS, right? Building Management and Data System, because you want your data in the BMS, and we agree you need the data in the application or the process you want. So there are different business models, obviously, Bryce, that would work, and that's a good wake up call, I suppose, in the industry. Don't buy solutions that don't work in your systems.
We've had wireless sensors for a very long time, and they never took off in commercial office land. They never took off because you think about it, like when you're building the construction phase of the project, it takes 2 or 3 years to build the building. And on that floor, you've got a 2 or 3 week window where you're running all sorts of cables for power supplies and networks and controllers. You're there, just run the temperature sensor cable in. You're going to be there for 2 weeks, run the cable and be done with it. So I just don't think that wireless sensors, there's no need for wireless sensors in construction. I don't think so. There are applications you need it, but I just think sometimes, it's not being too harsh here, but a lot of technology companies have a great product and a great solution for something, but they just don't understand. Apologies in advance if you're listening. They just don't understand exactly how buildings actually work and how the contractors work and how they're actually engaged in their contracts. They develop something which is very useful, just a little problem. Like, for example, I went to an exhibition thing, a few months ago, and I'm walking around and looking at all the indoor air quality sensors. And he has a sensor that it's a PoE powered sensor, right? It's a power over Ethernet powered sensor. That's great. We don't have PoE flooded through all the buildings. We got 24 volts AC everywhere. And I'm like, we want a 24 volts AC power supply, and we want BACnet MSTP, BACnet RS485. We need that. We don't want something else, because everywhere up there is 24 volts AC and BACnet MSTP. That's what we have everywhere. Don't give me a 240 volt power supply or a 24 volts DC power supply or a PoE power supply. So it happens all the time. These companies build great sensors on a workbench and test it. It's great, but that's not going to fit in the building.
Yeah, it's a real challenge when you're trying to, design a product that can then fit into the environment that it's designed for, right? You have to have that ingrained knowledge to, know that it needs to support BACnet, right? It needs to be integrated into those systems. I guess to go back onto your point about, wireless technologies as well. I guess IoT is, not necessarily synonymous with wireless. It can be implemented in a way that it is wired. And that's something that we're seeing adopted in the manufacturing space, right? It's local IoT. It's not necessarily internet. Mm-hmm. I know it's the internet of things, but it's not necessarily going to the cloud, right? And it's not necessarily going distributed architectures. It's just a mechanism to be able to connect everything together. So the internet of things could be, your BACnet networks. It could be your DMP3 drivers. It could be your IoT protocol of choice. So it's not necessarily synonymous with wireless. Wireless is just an option within the product suite of devices. And I absolutely agree that battery technology is going to be a very big challenge as we move forward, right? What do you do with the batteries at the end of the day? They're going to end up end of life. We have to look at recycling, putting that back into the supply chain. That is going to be a huge challenge when we start looking at this wireless technology.
It's probably a skilled person that's replacing the battery, even though it doesn't need to be, but it probably is going to be a $200 per hour person that's doing that battery change. Anyway, we're sort of like...
Yeah, absolutely. I think that it's the same with, smoke detectors, right? Smoke detectors throughout the building, not potentially commercial, but maybe residential, right? We're seeing those at scale for operations. These are huge challenges that not just the BMS and commercial space, the manufacturing space is also looking at these systems. Especially, we work in water treatment space, we work in water assets, and they have huge networks that they have to try and not run cables to in the future as well. So that's going to be a
just
challenge.
on that quickly. Don't want to digress to nowhere here, but I was working on a project that they wanted to buy wireless water meters. And there was like, say, 100 of these water meters. So this company came and like, it's a wireless water meter. And like, obviously me, as you know, I'm like, hey, I don't want the battery. I don't want the wireless thing. Just run the cables. This is a construction project. Just run the cables. Anyway, they convinced the customer to install these wireless water meters. Listen to this, right? How do you replace the battery is the question. I'm thinking of, you flip a lid over, the battery comes out, you replace it. You got to replace the whole water meter. And I'm like, anyway, they bought the things, but like, so now it's got a 10-year battery. Like every 10 years, a plumber goes there, isolates the water, the whole thing out, new one in for $500, $1,000, however big the pipe is, right? And somebody at that water meter company thought that was okay, that every 10 years they'll replace the whole water meter. And like, they're selling these things, and customers aren't probably realizing that in 10 years, you've got a big problem.
Especially if you're doing batch installs now, right? You're going to have a whole year of replacement.
Like $1 million worth of water meter replacements, yeah.
Over that project. So that's definitely going to be a challenging section. I guess we've talked about, what the future state of the manufacturing space is in previous episodes as well. I guess, do you have any sort of thinking's way that BMS is going to take it to the next level in terms of future trends?
Well, future trends, I bet you that like 99 out of 100 people would say to you the future trend is artificial intelligence. That's what they would say, right? Everyone would answer that question like that. What's the trend of what's the next upcoming thing with technology? And they would say AI. I just don't think so. Like we're in a legacy industry. BMS, process controls, legacy, dumb industries. You know what I mean? Like been around for 100 years. It's very difficult to do basic things. So I don't think that the next wave of technology is going to be AI stuff in buildings. We're like, not in our lifetime, although Phil, you look youngish, but in me and Ed's lifetime, we're not going to see that. I genuinely believe that in commercial office land, and I'm sort of repeating myself here from a few minutes ago, but it's got to come around to better integrating with people. So what I do a lot of at the moment is big portfolios that have lots of buildings, and if they have technology, they come to me and say, Bryce, we want you to restructure our BMS maintenance contracts. We want you to rewrite the specification, issue out to market, new scope, and the scope is not what it was before. It's not periodic preventative maintenance. There's this, how do they work with the platform? And like, when they get to site, and this is like slightly off topic, but do you guys do preventative maintenance in manufacturing? You do the same thing, right? So like, let's just unpack this for a moment. Before we had control systems, SCADA or BMS, you had to do preventative maintenance. So you went to site and you checked every single piece of equipment in a 12-month cycle, and that cost 1 day a week to do that. We priced it like that. In those days, there was no BMS. There was no graphics, no alarms, no trends, and nothing like pneumatics, relays, thermostats, time clocks, those days. And so you had to physically check things. And then over the last 20 years, we started networking the controllers together. And then we had a server and a trend. That trend shows that when the cooling valve opens, it gets cold. So over the last 20 years of our control systems evolving over 20 years and providing us with data that we can see things are working, we continue to do dumb preventative maintenance. Like the whole industry didn't say, hang on a second, why am I walking up and checking these sensors? There's a trend telling me that it works. You know what I mean? It's telling me that. So like, it freaks me out that in 20 years, we kept charging our customers a lot of money to do preventative maintenance, even though the data was available in your SCADA system or in my BMS system. And now what's happening is we're now packing technology on top with even more smarts to it that will tell you that thing's broken. The BMS company is still pricing preventative maintenance. There are thousands and thousands of buildings in Australia that have automatic fault detection running on a platform, and the BMS company is still charging them the exact same money that they used to charge them when there was no technology, there was no server, there was no networks. They're charging them the same flipping money. That like blows my mind completely. So this happens right now. You're paying $100,000 a year for a BMS preventative maintenance contract, and you go and spend, $30,000 engineering a technology platform, and then you spend $20,000 a year on a subscription service. So you were paying $100,000 to check everything manually. Now you're paying $120,000 to check things manually. So there's like, you cannot have a preventative maintenance contract costing $100,000 a year and pay for technology. There's got to be an offset. You've got to reduce the preventative maintenance contract by $20,000, so there is no extra cost. I do that with like a specification and a process to change that. But so what I'm seeing with owners nowadays is that they've been playing with technology for 5 or 10 years, getting to grips with it, and now they're sort of realizing, hang on a second, why am I paying twice for something? So the next phase really, I think, is, and it's again, that's circling back to the very first thing we spoke about, is that it's the people part. Before we're talking about how do people use the platforms better. Now we're talking about, you can't charge us to check everything physically if technology does it. The thing is, no company on earth wants to, you've never heard an account manager say, hey, customer, I see you just deployed some technology. I love that. I'm going to give you a discount. I'm going to invoice you $20,000 a year less. Yeah, you never saw that, right?
It's the dream, though, isn't it?
Yeah, so you've got to beat them with a stick to do that.
Yeah, and from those asset management points of view, yeah, like I totally understand that. That's a really great point, is that you've implemented these technology stacks to solve problems within your business, but you haven't adapted to the new state of things, right?
Let me tell you like one more ridiculous story, okay? Like BMS maintenance, instrumentation maintenance is not the same as car maintenance, right? So take your car for a service, change your engine oil, brake fluid, brake pads, they do stuff, right? If you don't get your car maintained every year, you will eventually get to the traffic light and you will not stop with no brakes, or your engine will seize. So you do periodic preventative maintenance. Periodically, you do maintenance in your car, and it lasts for a very long time. The BMS does not work like that. When you walk up to a valve actuator and you do preventative maintenance, you're just driving it up or down. You're just checking, is it working or not? You're not spraying WD-40 in there, greasing the gears of the actuator. You're not doing that. Unless you guys do, we don't do that. So preventative maintenance in the BMS or in control systems or instrumentation doesn't make the equipment last longer. So in year 1, you check the actuator. You drive it open, you drive it closed. Yep, it's working. Year 2, it's working. Year 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In the 15th year, the actuator fails. The gears were worn out. The motor's worn out. It fails. It still would have failed in the 15th year, even if you never checked it once before that.
Oh,
it still would have failed the thing.
That's not even a maintenance.
It's not. It should be called checking if it's working or not.
Yeah, that's right. It's not even maintenance. Yeah.
So you got $100,000 a year preventative maintenance contract on a BMS in a commercial office. Obviously, like industry is a bit more critical. It's critical, right? So it's a bit different. But you spend $100,000 a year on preventative maintenance. In 10 years, you've spent $1 million. In 10 years, what is the customer's return on investment for spending $1 million in the last 10 years? 0. We did things that didn't need to be done. If you install the thing properly, it commissioned it properly, in theory, a lot of the instrumentation would just live for 15 years. It would just work. Things break because they weren't designed properly, weren't installed properly, weren't commissioned. The valves are hunting all day long, so the motor's burning out, it burns out after 5 years, right? So like almost everything that we do is wrong or not ideal. Almost everything. I'm serious. Like I think about this a lot.
No, you're right. We see it too, Bryce. In a lot of our manufacturers, big motors, large bearings, and those bearings, they'll have vibration sensors or vibration monitors looking for the vibration to replace the bearing. But they still run on every 3 months or every year. We're going to rip it apart, replace the bearings, and put it back together again, and away it goes. And they might do it for no reason at all. There'll be no vibration issues. The machine's running well. I work for a bearing company, and bearings are almost meant to last for life. They last forever. But if, bad installation is the issue. But sometimes you're replacing things for no reason, only because, after 5 years or after a certain amount of years, we must replace this item. But it's that technology that helps us solve it. So it's not that industry is not adopting technology. It's industry is struggling to change their processes based on the technology we've been given. We're still staying
100%.
doing the old things.
100%. We're buying technology and we're not using it properly. Blah blah blah.
Mm. Oh, that's interesting. Look, Bryce, you on your channel, you've got lots of videos on how to, you've got courses on learning the ins and outs of BMS. And I think what you're sort of saying as well, that we need to keep educating industry, they need to keep learning how these systems work, how these applications work. Phil and I, we're always learning. So we're in a journey, learning new things. And for us today was a great learning curve around what you're facing. And we're similar experiences, but I've learned so much today. So what about you, Bryce? What's the next things that you're looking to learn about? What's getting you excited in learning?
I'm too old to learn things. I've forgotten more than I knew, right? So I've been deep in my area of my industry for 25 years, right? I've from day one I studied process controls. I'm deep into the stuff, right? So I don't generally try and learn technical things, but what I do think about all the time is how to do things at scale. Now, so I'm almost saying to you, so for example, say you want to improve the energy efficiency of a building of one, but that's quite easy. I write a specification, issue it to Honeywell, Siemens, Schneider, Johnson's. We have issue to the contractor. They execute the work, I sign off, everyone's happy, right? That's business as usual. That doesn't work on 50 buildings or 100 buildings or 1,000 buildings, where you got 100 buildings, 20 different contractors. It's different pricing models, different expertise of those companies. You wouldn't even want to start that job. So to do because what we're doing isn't actually working, sort of. We're not actually getting anywhere in a way, considering net zero, 2050, blah, 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 all that sort of stuff, right? We need scalable solutions to things. And technology is a piece of that puzzle, actually. So for me, my sort of learning is when I try different ways to scale a solution to something, a consulting solution, trying to restructure a client's portfolio of 50 buildings, across Australia. So I do that process. And my learning is, how do we scale a solution? And then I just test it. So my learning is by testing the market, reiterating things. So I'm always thinking about, I heard this thing once, right? I don't know how true this is, but if you Google it, there's people talking about it, right? It said that 80% of the buildings in 2050 already exist. 80% of the buildings in 2050, this is net zero 2050, already exist. So if we jumped in a time machine, 2050, and walked down Melbourne, Sydney, 80% of those buildings that we'd see already exist. Our focus needs to be in existing buildings. Forget the new construction jobs. Higher margins, 30% higher margins in existing buildings, direct to client, no builder to mess things up, right? We need to work in existing buildings, but there's thousands of them, right? Thousands. So if we want to use the building management system industry and process controls and manufacturing to have a meaningful impact on the planet, we need scalable solutions that can just smash through thousands of this, one building, that's not going to do anything, right? So yeah, it's not really an answer to your learning, but I am continually trying to think about how do I scale this thing to 1,000 boards. That's why I do some training, some stuff, a bit of training stuff, because I can't do it. You guys can't do it. We need the trades to do it. We need them to all be doing it, right? So yeah, always trying to find ways. Can I scale something, or can I teach somebody something and they will scale it within their business, blah, blah, blah.
Yeah, absolutely. Bryce, thanks for sharing your expertise with us today. It's been a fascinating conversation about technology, about people, about process, about the BMS industry. It's been really exciting to hear, and have these conversations.
It was a pleasure. Yeah, it was good. And also good to hear a bit of some of your challenges, because I've always sort of wondered, just before we go quickly, I always wondered, I wish I got into process controls, because BMS is a bit not as critical, right? But I'm happy to end up in BMS because you can't sort of offshore the manufacturing of buildings. You poor guys, stuff's getting offshored, right? So Yeah, it's like it's so good to talk to you guys and understand like how similar our industries might be. And you're on a journey, maybe 10 years behind us. So we'll see how that goes.
we got a few tricks up our sleeve still we can share with you. But definitely, Bryce, yeah, it's fantastic. Your insights really, really. You've given us a really good insight. I think anyone listening to this, if they come from manufacturing, they get a nice picture of what's happening with BMS, and there's lots of learnings here. So really, really appreciate you taking your time to join us today.
Thanks, guys. It's a pleasure.
Awesome.
Anytime.
And don't forget to subscribe to the Unplugged and IoT podcast for more episodes with industry leaders and innovators and great conversations on your favorite platforms out there. So we're on all the majors. So yeah, keep tuning into the episode. Thanks, guys.